All right, now let's head into section 1.4, which is really going to get at the meat of slope. Slope is going to be interpreted a lot of different ways. We're going to interpret it graphically, i.e. with a graph picture. Numerically, that's going to be with a table. And then symbolically, like, which is kind of what you're used to, m equals 2. That's a symbol, right? All right, so let's remind ourselves of the most important, one of the most important equations in all of algebra, which is y equals mx plus b. That's called slope-intercept form of the equation of a line. So if you graph y equals mx plus b, it's going to graph like a line. Slope-intercept, why does it have that name? Well, because that's what it gives you. If it's in that form, then m is automatically the slope, period. And b is automatically, well, 0 comma b is the y-intercept. All right, so let's look at this problem right here. They gave us this line, and they want us to determine the signs, S-I-G and S, of the constants, m and b. Now, why do they call them constants? It's because, well, every line, those are going to be numbers. They don't write m. They write y equals 2x plus 4, y equals 3x minus 7, right? They'll put numbers in for m and b. X and y don't get numbers because they're variables. You can only substitute a specific number in a bit to verify things, but you can't actually have x and y be numbers when it's all over with because they're variables. But m and b are constants, so they have to be numbers. So when you look at this lovely picture right here, you're supposed to judge, hey, is m positive or is m negative just by looking at it. Now, it would help here at this point to remember what we said in the last section, which is that this is a decreasing line. This line's going down as you move from left to right. We always move from left to right. That's how we read English. You start with the word determine. You start on the left and work your way to the right. You do the same for these lovely graphs. Okay? So we're going to start with the left. You'd say m is negative. If you want to use the negative sign, that's fine. Now, how do I know that m is negative? Well, because the line is decreasing. We learned that negative slope means decreasing. All right, now what about b? Okay, well, it hits it. Do you see where the y-intercept is? So that means b is negative as well. Oops. Because the line intersects the y-axis at negative values. Here, let me put it this way. Because the line has a y-intercept below the x-axis, i.e. in the negative area. There you go. Now, of course, I could ask you all sorts of these. I could give you ones where there's 0. That would be a flat line. Or give you ones where they're positive and stuff like that. So that's a great question to ask on exams. All right, next, you're supposed to determine whether these lines are parallel, perpendicular, or neither. Okay, well, we have a little bit of an issue because they don't exactly tell us where the slope is on this back one right here. So this front one, you can see the slope is 2/3. Hopefully you can see that. So on the first one, m is 2/3. No problems, no troubles. There you go. But the second equation is going to give us a little bit of grief because we don't know what the slope is right now. Oops. All right, so we're going to have to find it. All right, now to find it, you're going to want to get it in y equals mx plus b form. That's not the only way you can do it, but I think it's the best way. All right, so we want to get y by itself. That's the whole point of this slope-intercept form. Do you see how y is all on his little lonesome? Yeah, if you don't see it, let me show it to you. So over on the left, do you see how y is all by itself? That's what you want. You want y all by itself. Okay, so we need to get y by itself. So I'm going to subtract the 3x. And of course, if you do it on the one side, you got to do it on the other side. That keeps things cool. So that's going to cancel. I hate the word cancel. That's going to make this disappear because 3x, take away 3x is 0. So what are you left with over on the left-hand side? Well, you're left with 2y equals. Now, negative 3x and 8, they're not like terms because one has a variable and one doesn't. So you just have to write it. And you could write 8 minus 3x, but since we want mx plus b, it's kind of better to do it this way because we're getting ourselves set up for it. Now we're almost done, but we got to get rid of this 2. Now the operation between the 2 and the y currently is multiplication, so we're going to divide. And of course, if you divide one side by 2, you've got to divide the other side by 2. Okay, that's going to leave you y over here because the 2's and the 2 are going to cancel. Right? Sorry, divide away. They turn into 1. So now here's the tricky part. A lot of students want to do this. They want to say, oops, hey, that's negative 3/2 x. Okay, which is great, negative 3/2 x. Or you could say, if you'd like, you can say negative 3 over 2x. That works too. But my math lab likes the negative out in front, so I don't like it because I think it's easy to kind of blur those two lines together and make it look like one big line. But so if you're going to do it this way, be careful. Make sure you write that negative clearly in front. 3 over 2x. Seems good. Plus, and now here's where people get hung up. It's the whole thing gets divided by 2. Not just the front number, but all of it. The entire right-hand side had to be divided by 2, which means you don't get to write plus 8. You have to write plus 4, right? Because it's 8 over 2 makes 4. Now, what's the slope on this? That's what we were really looking for. So the whole reason for doing this was to get m equals negative 3/2 right there. All right. Now, since we know that m is equal to negative 3/2, that helps us because now we know that if the one slope is 2/3 and the other slope is negative 3/2, that means that these lines were perpendicular. Right? Sorry, I had to make that work smaller. All right, so perpendicular because the slopes are opposite negative reciprocals, opposite reciprocals. Opposite just means one's positive, one's negative, and reciprocal means they're flips of each other. One's 2/3, one's negative 3/2. All right, so now let's look at the other one. Now the other one has this whole x equals 2, y equals 4 business. But we got to be careful about this just for a second. So let me remind you that x equals 2 is a vertical line, right? And then while we're on the subject, y equals 4, oops, x equals 2 is a vertical line. Y equals 4 is a horizontal line, right? Oopsie. And I said it in the other videos, but I'll say it again. Hopefully we all know that horizontal and vertical are perpendicular to each other. That's how buildings get held up, right? That they form right angles with each other. So these are perpendicular. It's the special case. Horizontal and vertical lines are always perpendicular to each other. Right? So for example, you can imagine, let's see here, insert. If you had a vertical line like this, doesn't matter where, and then you have a horizontal line as well, like that, I know the x and y axis work as well because they're vertical and horizontal. It's perpendicular, right? Of course it's perpendicular. Let's not, let's get real here. They're going to hit at a right angle. All right, done with that section. That little bit, excuse me, of that section. Okay, so now let's talk about the other method for graphing linear equations, which is probably the method most people use. It's the one where you start with your intercept and then kind of go up and over, down and over, down and over. All right, so the first thing we're going to have to do is, if you're going to use this method, you have to get into y equals mx plus b. If it's not in that form, you're in trouble. All right, so let's look at this particular one right here. We want to get this into y equals mx plus b. Now there's a couple ways you can go. You can distribute 2 times y, 2 times 3 makes 6. But this is multiplication, right? So why don't we just divide by 2? Wouldn't that be simpler? I mean, you could do the other method too if you like. I mean, it'll work. It's just going to take you a little bit longer. Okay? All right, so if you divide away that 2, what's left on that left side? Y minus 3x, right? Equals 4. All right, then you just add 3x to both sides. Oops, went a little too far there. Okay, that means y equals 3x plus 4. Now, our reason for doing this was in figuring out m. M is 3, right? The number that's multiplied by your x, that's 3. And for our purposes, we're going to write it 3 over 1. And I want to remind you that that is vertical over horizontal. Now, since these are both positive numbers, you can think of this as I'm going to go up, up 3, because 3 is positive, and then I'm going to go right 1. That'll work. All right, so let me go get my graphing program, and I'll be right back. All right, now I put down my starter dot. So let me make a note of that as well, just for starters. All right, so we know that the slope is 3. That's kind of a big deal. So that's going to give us how we're going to rise and run and stuff like that. Okay. Matter of fact, I'm going to underline the whole thing. That's really important to us. Then we also need a starter point. Okay, so that's what the y-intercept does for us. So we're going to have a starter point of 0, 4. Because the y-intercept is 4. See it right there? So that's also a big deal to us. Okay, so that gives us our starting point. So I put a dot at 0, 4 because I better box this whole thing so that way you guys can see it really clearly. Okay, there's your equation, y equals 3x plus 4. Don't pay attention to the starter equation that they gave you because it just wasn't good, wasn't pretty. So we're going to pay attention to y equals 3x plus 4. All right, so that means that my starting point is 4. So I start at 0 or 4. So I put a dot there at 4. And then I'm going to go up 3. So I'm going to count off 1, 2, 3 to the right 1 and put a dot. Poof, like that. So up 3, right 1. Now I'm going to do it again. Up 3, right 1. There it is. All right, now I'm in a little bit of trouble because I've run out of space on this grid and there's all this empty space down there. Right? So I need to be able to fill in those empty spaces. So that brings in another faction, which is the slope. So you can do slope a couple ways. You can do it the way we did, which is up 3, right 1. But you could also go, hey, if it's positive 3 over positive 1, isn't that the same as negative 3 over negative 1? Which wouldn't that mean that we go down 3 and then left 1. That'll fill in the other direction, right? So one way went, this guy over here went to the positive right, so up and right, up and right. And then we could also go down and left, down and left. So I could start back at my starting point, 0, 4, and I could go down, 1, 2, 3, go to the left 1 and put a dot. I decided my dots were too big, so there it is, down 3, left 1. And I'm going to do it again, 1, 2, 3, left 1. There it is again. And then I'm going to do it again, down 3, left 1, put a dot. There it is, and then I did it again. And you can see the line, but you got to draw the line. It's not enough just to have it there. And so you draw it in like that. And there you go. And my students, again, I demand that you fill out every single point that fits on the grid, which isn't that hard when you're doing it this way because you just keep going down and left, up and right, right? And you can go either direction and you should be able to fill it in. But don't forget your starting point is on the y-axis. Some students for some reason want to make it the x-axis, but you want to make it the y-axis, 0, 4, up there. You can also do it with your calculator just by going to y equals, clearing out your old equation, typing the new, and then pressing graph. Which doesn't really give us a lot of help for filling out the grid, which is what we're supposed to do for the tests and stuff until you go to second table. And right in there are a whole bunch of points.